Okay, for 2.11, it wants us to find the commutators for s squared along with each of the spin operators. And it wants us to do that first in matrix notation and then again in a more generalized abstract form. So we'll go ahead and do both. So for reference, I wrote down the s squared operator along with the spin x, y, and z operators there. And as a reminder, to calculate the commutator for a and b, you do ab minus ba. So we'll go ahead and start with the first one. So we'll have to do s squared sx minus sx s squared. So we'll start with s squared, which is 3/4 h bar cubed, or h bar squared, I mean. 1, 0, 0, 1. And then sx, which is h bar over 2, 0, 1, 1, 0, minus, same thing backwards, h bar over 2, 0, 1, 1, 0, and 3/4 h bar squared, 1, 0, 0, 1. All right, so we'll go ahead and pull these out here. So we'll have a 3, we'll have h bar cubed over 8. All right, and then the matrix will have 0 plus 0 is 0. Yep, and then 0 plus 1 is 1. 1 is 1, and 0 plus 0 is 0. Okay. And then minus, and then we'll have the same thing out here. So 3 h bar cubed over 8. And we'll have 0 plus 0 is 0, 1, let's see, 1, and 0. All right, so then if we could pull these out, but we'll have 0 minus 0 is 0. We'll have 1 minus 0 is 0. 1 minus 1 is 0, and 0 minus 0 is 0. So that'll be 0. So s squared along with sx equals 0, and that means it does compute, or it does commute, which means that we can know the measurement for s squared and sx at the same time. So if you remember when we had like sx, sz, for example, and we got I h bar sy, it was not 0, so they do not commute, which means we can't know the measurement for sx and sz at the same time. But for these we can. So probably didn't need to erase all that, but we're going to have our s squared again, so 3/4 h bar squared, 1, 0, 0, 1, the identity matrix. And then let's do sy. So sy is h bar over 2, 0, negative I, positive I, 0, minus h bar over 2, 0, negative I, 0. And then 3/4 h bar squared, and identity matrix 1, 0, 0, 1. All right, and so because this is the identity matrix, this is like multiplying it by 1. We're always going to get the same thing. So we're going to get 3 h bar cubed over 8 again, and then we're going to get this back again because this is basically like multiplying by 1. So we're going to get 0, negative I, 0, and same thing here, minus 3 h bar cubed over 8, and we'll get this back again, 0, negative I, 0, and we'll see 0 minus 0 is 0, negative I plus an I is 0, I minus I is 0, 0 minus 0 is 0, so we'll get 0 again. That's y equals 0, and probably obvious by this point, but we're going to get 0 for sz also. So sz is 1, 0, 0, negative 1, 1, 0, 0, negative 1, which means down here we're going to get same thing, 1, 0, 0, negative 1, minus 1, 0, 0, negative 1, along with our 3h bar cubed over 8 but then we'll have 1 minus 1, 0 minus 0, 0 minus 0, negative 1 plus 1, and that'll be 0 also. So s squared sz equals 0. All right, so they all commute, which makes sense because s squared operator is really just telling us that it's a spin 1/2 system. So we can know that it's a spin 1/2 system, and we can get the measurement for spin in the z direction at the same time. We can know that it's a spin 1/2 system, and we can know the measurement of spin in the z direction at the same time. All right, so let's go ahead and calculate this in another way. So we know that, we know this, first of all. So we know that s squared sx is equal to s squared sx minus sx s squared. We also know that s squared is equal to sx squared plus xy squared plus sz squared. So we can say that s squared here is really sx squared plus sy squared plus sz squared, comma, sx. So that also means that we can do sx squared sx plus sy squared sx plus, we're out of room, sz squared sx. All right, and then if we write all those terms out, then we have sx squared sx minus sx sx squared. That's just expanding this out, right? And then we have this one here, so plus sy squared sx minus sx sy squared. And then this last one, we'll have sz squared sx minus sx sz squared. All right, so we can see these terms cancel out. All right, so now we can start rearranging some things, but we got to be really careful with how we do it. Remember, these are all matrices, so the order matters. So we can't just pull out an sy of these two terms, because if we were to multiply them back, we got to remember that this has to go in the front and this one has to go in the back. So again, I got to be really careful with how we do this. I will pull out an sy from this term here. So sy and then sy sx, and it'll be more clear why we're doing this later. But for right now, we can do that. And then minus, we'll pull out an sy from here too, sx sy. But I'll put this one in the back. Remind myself, I got to put this sy goes on the end. This one goes in the beginning. All right, so then I'll do the same thing here. So plus sz, sz, sx minus sx, sz, sz. All right, so now we know that x, sy is equal to I h bar sz. And we also know that, that this is calculated by doing sx, sy minus sy, sx. And that equals I h bar sz. So if we were to rearrange this and solve for sy, sx, then we get sy, sx equals sx, sy minus I h bar sz. So we can just plug that in here. Sy, sx, sy minus I h bar sz. Minus, we can do the same thing here. So this is sx, sy. So that's sx, sy is equal to sy, sx plus I h bar sz. I'm just keeping the I h bars on the right side of these. So sy, sx plus I h bar sz. Remember this sy here. And then same thing for these here. For this one here, though, it's not in alphabetical order. So S, X, S, Z is actually negative I, H bar, S, Y. Or if you can do Z, S, Z, S, X, and then it would be positive. Either way, as long as you get those signs right. So if I were to do S, X, S, Z minus S, Z, S, X, then I would get negative I, H bar, S, Y. Solve for S, Z, S, X, then we would get S, Z, S, X is equal to S, X, S, Z plus I, H bar, S, Y. So we'll swap that in here. So we have S, Z, S, X, S, Z plus I, H bar, S, Y minus, and then do the same thing, solve for S, X, S, Z. And that's going to be S, X, S, Z. Looks like it's going to be equal to S, Z, S, X minus I, H bar, S, Y. All right, S, Z, S, X minus I, H bar, S, Y. Remember that S, Z. Okay. So now we can go and either we can see if we can cancel here. Looks like we can't cancel yet. Let's go ahead and multiply these back in, remembering that this needs to go in the front of these terms, and these need to go in the back of these terms. So let's do SY, SX, SY minus, these are constants, so they can go to the front. I, H bar, this one has to go in the front. SY, SZ minus, and this SY goes in the back. So SY, SX, SY. Remember to distribute the negative. So this is minus I, H bar, SZ, SY. All right, so next one is plus. This one goes in the front. SZ, SX, SZ plus I, H bar, SZ, SY minus, this one goes in the back. SZ, SX, SZ. The minus distributes, so this is plus I, H bar, SY, SZ. Okay, and if I did this right, we have I, H bar, YZ, I, H bar, YZ, positive and negative. We have YXY, YXY, ZY and ZY, cancel, and ZXZ and ZXZ. And so everything cancels, and then so this is 0. And we can go through all of that for the other two, but it's pretty tedious, and it's all kind of the same. So if you want me to go through the other two, I can do that, but it would make for a long video. So assuming that that isn't very interesting and it's all really just doing the same thing, the other two, I'll go ahead and stop it here. But let me know if you want me to work out the other two.